Hello and welcome to lecture series on Introduction to Electrodynamics. Suppose we have a function of one variable f of x. So the fundamental theorem of calculus states that you can integrate this function or relate this function using this mathematical expression. So in fact, we can write this in a different way. We can write a to b f of x dx f of b minus f of. So f of x, the capital F of x, in fact, is defined by df of dx. So this is just a mathematical statement, though. So what this mathematical statement is saying. So if we want to find integration of a function f of x, so you can perform the integration by two ways. The first way is to find the differential changes, which we can express the differential change df of dx into dx. So first you have to find the differential change in function f of x and then add all those changes from interval a to b. Then you have the same value as you will have if you have final initial value differentiated by or subtracted by the final value. Geometrically, we can see this like we have this function. Function is f of x and it's going from this way. So this is initial value, this is final value, and say you have some infinitesimal dx. So here we have f of a. Somewhere here we have f of b. So if we want to perform the integration on this function f of x, we have again two ways to do this. The first is we have to find df of x, which is just this differential change corresponding to this df switch, and add those all the small changes, say divide into so many pieces, and all the changes are df of x, say df1 plus df2 df3 plus so on, and express them dfn dx dx. So if we want to add them, that means we have to perform the integration, and integration from a to b will become df or dx dx, right? So we can do either into pieces, or you can just do f of b final value minus the initial value. The result will be the same. So if we want to find the change in function f of x, either you can find the change in pieces or just you can perform final and initial value. Take the final value and subtract it from the initial value. So this is the statement of the fundamental theorem of calculus. So as we have this involve the differentiation or the derivative of the function. This fundamental theorem we can see from here. So for vector calculus, we have three different types of differentiation. We have gradient, divergence, and curl. So as we have three type of different derivatives, so we have three different types of fundamental theorem corresponding to each of the derivative, like fundamental theorem of gradient, fundamental theorem of divergence, and fundamental theorem of curl. And we will discuss all these three in details in next videos.